scientists are working on Earth-based quantum communication systems that use quantum particles to transfer data and communicate with aliens. This technology is more secure than traditional communication methods. It is envisaged that the technology would one day deliver unbackable high-speed internet. This video will be interesting as I will tell you that there is a possibility that photons, or light particles, can travel long distances without losing their quantum nature. A recent study shows scientists can utilize photons to seek quantum messages to detect extraterrestrial transmissions. According to new research from the University of Edinburgh in Scotland, alien civilizations may send quantum messages across great distances via space, something humanity may soon be able to achieve. To understand how this could work, we must first learn about quantum phenomena and how quantum networks emerged on Earth. What are the advantages and disadvantages of quantum communication in these two very different environments? A new paper was published by physicists Arjun Bera and Jane Calderon-Figueroa late last month in the journal Physical Review D. The paper was published as a literature review and a thought practice about one potential version of interstellar communication. Researchers claim in Physical Review D on June 28 that light particles, or photons, could be transferred over large interplanetary distances without losing their quantum nature. This suggests that scientists looking for extraterrestrial communications may also be looking for quantum transmissions. Earth-based quantum communication, a technique that employs quantum particles to transfer information and has the potential to be more secure than standard, or classical, communication, is currently being developed by scientists. Intelligent extraterrestrials, if they exist, may have used quantum communication as well, according to theoretical physicist Arjun Bera. Arjun Bera and Jane Calderon-Figueroa discovered that the same quantum processes that correspond over smaller networks on Earth could be applied across vast swaths of space. Rather than relying on a more conventional medium like fiber optic cable, communications might be possible through the air or in the lack of air. You can only find such interesting facts on our channel. Now, this is something interesting, a massive breakthrough, which means we can communicate with lives on other planets or space, the beings we call aliens. Just wonder what if this theory comes true and the experiments succeed. Arjun Bera, a theoretical physicist, speculated that they might have used quantum communication if aliens existed. Decoherence, which occurs when a quantum particle loses some or all its distinct properties when interacting with its surroundings, is a substantial barrier to quantum communication. Quantum states are often thought to be highly sensitive, and any external interaction destroys that state. Bera explained. Because matter in space has a much lower average density than matter on Earth, particles can travel further before becoming decoherent. As a result, Bera and Jane Calderon-Figueroa of the University of Edinburgh calculated the greatest distance that light, namely X-rays, could travel through interstellar space without being damaged. Their simulations demonstrated that quantum particles might be broadcast across vast intergalactic distances. It could survive a journey of at least hundreds of thousands of light years, a bigger distance than the Milky Way galaxy. That indicates places many light years distant in this case. People seeing the entangled particles from opposite ends would see the same information. Entangled quantum particles function as a group, share information, and are inherently linked. Consider the quantum entanglement state like the delicate layer on one of those massive bubble dippers. When all of the particles in the detergent mixture come together, they can perform seemingly magical feats. However, any disruption to any film segment destroys the entire experience. Entangled photons are protected on Earth by fiber optic networks. Fiber optic technology operates by bouncing light beams along cores composed of glass or plastic in small, single-mode cables or thicker multi-mode cables. That indicates that on Earth, the medium is glass, while in space, it is thin air. You're correct if you assume transmitting beams through glass instead of air is much more difficult regarding resistance and throughput. That is one of the reasons why fiber optic networks, like practically other communications networks, use a technique known as a repeater. This device is normally incorporated into the network infrastructure and absorbs and enhances whatever signals are sent, and it applies to both wired and wireless internet. Using astronomical data and computer models, physicists Arjun Bera and Jane Calderon-Figueroa characterized X-rays migration between 100 neighboring exoplanets and Earth. At this distance, it was decided that the quanta would most likely not encounter any substantial barriers. Scientists spend years researching and finding a single peephole that can help us become closer to space. It's fascinating to wonder what space and other universes can offer Earth. It is plausible that quantum communication mediated by photons could be established across interstellar distances, particularly for photons in the X-ray region below the electron mass, the researchers documented. However, in the quantum domain, it is not so simple. Explained another scientist, David Oshellam. How can you repeat a single photon in an entangled state when gazing at it destroys the state? As commanded by quantum mechanics observer effect. There is no option for a repeater in space. Fortunately, there is also no real necessity. Sending light through space seems to negate this difficulty. Oshellam says, although air or lack of air is a less difficult medium with less resistance, there are still problems. What could damage quantum and optical signals passing across the vacuum of space if you move past our atmosphere and into space? There are impacts such as gravity, interstellar particles such as dust, and anything that could scatter light, such as shining a flashlight into a little dusty room. Edinburgh researchers, physicists Arjun Bera and James Calder Figueroa concentrated on signal fidelity and how to receive the wobbling photons from space best. In outer space, the problem isn't decoherence, which is the most dangerous enemy of any quantum data network, causing particles to fall out of the quantum state and destroy the connection. And the wavelength you choose matters because of the qualities of certain wavelengths, such as the ability of X-rays to pass through most of the human body versus optical light, which casts a shadow instead. If you are a nerd like me and are fascinated by space, you will know how these things work. Signals in fiber optic networks are physically contained because they bounce within the topology of the cabling. Because single-mode cabling allows the signal to bounce less, it can go farther without deteriorating or losing oomph than multimode wiring. There is no bounce in space, but there is also no containment. Gravity pushes and pulls the photons in any direction. There are other concerns in the air on and around Earth, such as humidity. Consider flashing a light into the fog. A good quantum signal would have to behave similarly to your car's special fog lighting, attempting to avoid dispersing the light by skirting around the humid cloud. According to Oshellam, there is an existing precedent for delivering quantum communications via the air utilizing satellites. The Chinese satellite MISHIS, for example, has sent signals over great distances to and from the Earth's outer atmosphere and low Earth orbit. And if the stations that transmit these signals are in high places, such as mountains, they can escape many problems associated with higher humidity. Because air and fiber are separate mediums, Oshellam believes that operational quantum data networks will require a multimodal approach. Almost all existing communications operate like huge trees or fractals, with massive trunks connecting the most populated locations before branching into smaller and smaller delivery networks. According to Oshellam, the trunk of a quantum communications network might be satellite-based, while cities can network their infrastructure of houses and businesses using fiber. It's all about figuring out the best approach to keep photons entangled. Every photon count, adds Oshellam. However, based on physicists Arjun Bera and James Calder Figueroa's findings, they propose ways of searching for extraterrestrial quantum dispatches. Quantum teleportation is one sort of potential communication to look for, in which the attributes of a distant particle can be transferred to another. Scientists might hunt for such simultaneous signals to identify alien quantum messages because the technology requires both quantum and conventional communications. And we hope that this theory comes true. That's all for today, my friends. We hope to see you in the next video. Until then, make sure to like this video and share new research and scientific work with you. Until then, you share this with your friends. Also, click the bell icon for more updates. Until next time, folks.